Alright, so today we'll talk about some different kinds of instructions which are called branch instructions. Now so far we have learned about many different instructions, and also recently we talked about flags, right? So now we have an understanding of how the flags are set, especially the last four. We have some more flags, but we just started with the significant ones, so we just now know the C, Z, N, and V flags. So let's look a little bit about the programmer's model. Remember, this is the list of the registers we have in the architecture we are using. Now in this architecture, so far we talked about accumulators, we talked about the condition code register where we have all the flags. So today we'll also explore the program counter. Now the program counter is a 2-byte register, but that is also controlled by the microprocessor. Okay, so that is not something like you will load the data. You can, but you will not, because it will be controlled by the microprocessor. So what we have there is that, as you have seen, that we store all the data, even the instructions, in the memory, right? Now let's say you have a bunch of lines, like let's say 50 lines of code. Okay, in general those lines are excuse me, those lines are stored in sequence, right? I'm saying in sequence in the memory locations. So the first thing is, if you are saving in sequence, still you need to keep some track of which line will be running next. And then it is also possible, just like the higher level language, you have some kind of loops there. We have not explored any loop yet. But remember, in high level language you have all different kinds of let's say conditional coding, right? Meaning you have, let's say, some if then else structure. You have different kind of loops like for loop, while loop, right? Do while loop. So in those cases what happens, that the lines of your program do not run in sequence. You break the sequence, right? I'm saying sometimes you keep repeating some lines for, let's say, 10 times, 20 times, 100 times, right? Sometimes you skip some lines. For an example, then if then structure, if else structure, what do? You have a branching, right? Either you run these or run these, something like this, right? So pretty much you can realize we will have some kind of branching in our course as well. We have not looked at it yet. I'm saying that so far we just have seen, okay, I have 10 lines, we'll be just running 10 lines in sequence. But there is a possibility that some lines might be skipped, some lines might be repeated a couple of times, just how we have the loops. So pretty much like, since you have the high level language written like that, when the compiler translate every single line into assembly program, you will have something similar here as well, right? And for those cases we need these specific kind of instructions called branch instructions, because all these instructions will be used to make all different kind of branches. And because of those branchings, some lines may be skipped, some line may be repeated. You know what I'm saying? So pretty much the lines will not be running in sequence anymore. I'm saying at this point, so far we have seen all those sequence execution. I'm saying sequence of execution, but it will not be the case. So program counter is the one which basically holds the address of the next instruction. You see that all the instructions at the end, when the instructions get converted into hex, right? I'm saying it's not hex, but we just write everything in hex. And you have seen that we have tried to show you a table like this, where, for an example, let's say if you consider this 0, 0, 0, 0, that's the address of the first line. Okay, and 0, 0, 0, 2, the address of the second line, because this is the 0, 0, 0, 0 is address of basically 86, which is the opcode for the first line, right? How do you get 8623? It's just the object code. Remember, we just learned how to write the object code, right? In quiz 2, how to write the object code for each line. Similarly, if we write the object code for the second line, that will be 8B1A, and the address of 8B is 02. Okay, so if this is your byte 0, this is your byte 1, right? So this is your byte 3. I'm sorry, byte 2. Then this is your byte 3. So this is going to be byte 4. So as you can see that just the address of the first byte of the instruction is basically the address of that instruction. I'm saying only thing that you need to know is what is the address of the first byte. Then you will know what will be the address of the next byte. I'm saying next byte, you will automatically know this. And then the microprocessor knows exactly how long that address will be, or that line object code will be, because it knows whether this is immediate or this is extended or this is inherent. So it knows exactly how long that instruction will be. So automatically it loads the address of the next byte. So pretty much now you see we added one rightmost column here where we are showing you that what will be the content of the program counter register at that moment. So that means in the line 1, when the program microprocessor is executing line 1, the program counter is holding 0002, which is basically the address of the second line. When you are running the second line, it is holding 0004, which is basically the address of the third line. Do you see the address of the third line at the very left side? This is the address of the third line. Now when you are executing the line number 3, microprocessor holds the address of the fourth line. So pretty much every single time the program counter is the one which holds the address of the next line to be executed. Again, why we need this? Because at some point we will see that lines are not executing in sequence. It may not be the next line which will be running next. It may be some other line after 20 lines or apart or somewhere else, or you are probably repeating some lines. Okay, so that's why we need this PC counter register. You are not the one who is controlling this. It's just how you write the code. Based on that, microprocessor is the one which basically keeps track of the next line to be executed. Okay, so pretty much like you don't have to worry about the program counter. It will be automatically updated, but you just need to know there is something which is basically keeping track of next line to be executed. Now let's look at a little bit more details. As I said, we are going to explore this new kind of instruction. These instructions does jumping or branching. Okay. Now what does it mean? That means you basically skip some lines or you repeat some lines, meaning you basically transfer the control of the program, right? I'm saying control means how the program is running, how the program is executing different lines. So in general, this is a framework that how the branch work. For an example, you might see some line like this. For an example, BRA, this is a branch instruction, okay? And with each and every line like this, there will be a label. Okay? Now the label is nothing, just a name. You can give any name you like, okay? Not longer than, let's say, 8 characters. Whatever name you want, just give the name. So what happens is, let's say you have a bunch of lines, but if you just write BRA some label, let's say you just give the name label 1. Any name can be possible, okay? You can give your name as long as it is less than 8 characters. If you just write BRA label 1, after this line, the next line to be executed will be this one. So pretty much, whatever you have in the middle, all those lines were skipped. This is the way how we can match exactly the loops and while loops, do while loops, if then structure, case structure that you write in the high level language. Pretty much all different kinds of things can be taken care of just writing the branches. Now remember, as I said, we are trying to explore the branch instructions, meaning that's not one instruction, there are a bunch of branch instructions we have, okay? And all the branch instructions start with the letter B. So there's, you'll see it in the set of instruction again, so all of those. So the idea is you will just write a branch instruction and then you will put a label in the right side, and then your program will jump into that line, okay? Now, in those cases, this will be happening. For an example, let's say you have written from the first line, so this is the address of the first line. When you are executing the first line, the PC is holding the address of the next line, right? Which is 0002, let's say. You see the address of the next line is 0002, right? Here. When you are executing second line, the PC is holding the address of the third line. You see the third line, the address of the third line is here, which is 0004. But when you are executing the third line, maybe there is a branch, right? You see, this is also a branch instruction. That's an exception. Starts with a J. That's the only one. So, which is also called jump. So, when you do this, look at this. The PC should hold 0007, but instead, since it is jumping to where? Save, right? Save is, remember, a label. It's just a name. Don't go by the word save. What does it mean? Don't go by that. It's just a name, okay? So let's say the save is here, okay? Now remember, in the middle, you probably have a bunch of lines, okay? You see the difference in the address? This is like 0004. The address of the line with the save is 0200. You see how different the address is? So pretty much there is a bunch of address lines here in the middle. But you are probably jumping from here to the next line. So your PC will be holding the address 0200 instead of 0007, which should be the next address. But we are just trying to show you that, look at this. When you are in the third line, instead of holding 0007, which it should, because that's the address of the next line, it will be holding basically 0200. Because that's where the next line is located. Remember, the next line to be executed may not be the next immediate line, right? After a long, because of how you are jumping, branching. Okay, now, at this point, we're just trying to show you that how the PC content is changed. But how these branch work, we don't know anything yet, right? Now, before we look at those, let me tell you a couple of more things. One is, in case of this branching, there are two different types of branching. Because one possibility is you might be skipping some lines and branching to somewhere. So meaning something like this. For an example, let's say you are here and you branch to this line. So in the middle you might have something, you skipped it. This kind of branch is called positive branching because you are moving forward, okay? Meaning downward, I would say downward in the line, okay? Because you are branching somewhere to a line which is downward than the line you were at this point at, right? But it's possible that you might be branching backward, meaning the line before you are here at this point where you are, because you might want to repeat some line. In those cases, you might be jumping backward, right? You know what I'm saying? So for an example, let's say you are here, but you might be branching backward to some previous line. You understand what I'm saying? So that means backward jumping. I'm saying forward or backward. Now, in all forward jumpings, we call those branching positive branching. Backward, we call negative branching. It's just, just to differentiate both of those. Now, you might think like, in case of negative branching, we probably are trying to repeat some lines, right? I'm saying we are going backward, repeat it. We are going backward, repeat it, right? Because every time you go backward, you are trying to repeat some lines again, right? Pretty much that's the idea. But when you are branching forward, it may not be like repeating. It may be like skipping some lines, right? And there are two kinds of branch instructions. Remember, the last one was two kinds of branching. Now this is two kinds of branch instructions. Now,
where you just tell it to jump, and the other one
yes. Now, it's pretty simple that there are two instructions we have in the set of instructions. One is JMP another one is BRA. This means branches and jumps. These two instructions, these two branch are called unconditional branch instructions, meaning whenever you write this, doesn't matter what happens, your program will jump, will branch for sure. There is no condition will check, okay? Meaning there is no conditional thing, it will branch. It will just jump to that line where your label is located, okay? But in case of conditional branching, it's something like the program will check or match some condition. Just like, for an example, when you write the C++ program, what do? You just write sometime what? If x greater than 0, right? For an example, you just write this. If x greater than 0 something, that means what? The x greater than 0, this is the condition, right? If this condition is met, then only those lines will be executed, right? Similarly, in the branch instructions, in conditional branch instructions, there will be some condition to be met. If the condition is met, then only the branch occurs. You see what I'm saying? It's, just how our high-level languages are. I think you have all seen this, right? If something, even in case of all those, like even the while loop, how do you write the while loop? While, still there is a condition, right? While parenthesis x greater than 0, let's say, that means only when x is greater than 0, then the loop will be running, right? Loop will keep running as long as x is greater than 0. Every single time you check whether the x is 0, and then if it is true, program will keep running, right? That's exactly in the conditional branching, we will have some kind of condition to be met. Now let's look at some examples. Now, for an example, let's say, again, now we are exploring the conditional branching. So pretty much in all the branch instruction, you will find a condition to be met, right? If the condition meets, the branch will occur, otherwise branch will not, right? Now, let's say you are given these 3 lines. Now, in the third line, you see there is a branch. BMI, that is a branch instruction, and the save is a label. Now remember, don't worry about the name. It's just a label, okay? And at this point, we even don't want to know where the label is. We just want to see after these 2 lines, I'm saying in the third line, whether the branch will occur or not. Can we understand that? Can we find that out given the condition of the branch? Now, again, how do I find the test condition? Meaning, how do I find the condition of the branch? Just look at the column 3 for the branch instruction. Again, the column 3, remember the column 3, we have some notations, right? For each and every instruction, we have some notation written, and based on the notation, meaning based on the expression and the notation, we figure it out what is the condition is, right? Now, okay, now let's come back there. I'll get back there. So let's say you are given these 3 lines, okay? Now you have to decide in the line 3 whether the branch will occur or not, right? Now remember, this is just a yes/no question. All you will tell us is yes, the branch will occur, or no, branch will not. Now what happens whether the branch will occur or not? Now, if the branch does not occur, then the next line to be executed will be the 4th line, right? I'm saying whatever you have after BMI save, that line will be executed, right? If branch does not occur. Now, if branch occurs, what happens? You jump into that line where you have the label save and then something written with that, right? It might be, negative branching, might be positive branching. We don't know yet. We don't want to know it yet. But the only thing that we are trying to figure it out, whether the branch will occur or not. Now, what we do is, once we have such instructions with the branches, we look at the column 3 of the set of instructions. Can you just take a moment and look at the BMI? Again, all the instructions are alphabetically sorted, right? Do you see the BMI? In the set of instructions, should be, I think, in the page 2. Look at the BMI. In the column 3 of the BMI instruction, we have the test condition written, and you will see the test condition there is n equals to 1. So pretty much we will find the test condition from the column 3 of the branch instructions. Check the column 3 of BMI. Okay, so do you see n equals to 1 there? So that means that is the condition of the branch to occur. Now, that means what? N is what? N flag, right? We know the flags right now, right? So now this is where all the flags come into the picture. And so far we just know, okay, now because of some instructions, some addition, some subtraction or something, these flags got set or these flags got cleared. Now this is where you will see why we need flags. Okay? Now, what exactly happens? Now let's look at the line 1 again. In the line 1, you are loading a data which is 20, right? 20 is the data here, right? Into accumulator A, right? In the line 2, you add, again this is the data, right? 34 is the data here as well. Look at the instruction, that's immediate, right? So in line 2, there's 34, which is the data. You just add that 34 with 20, right? Because, you know, that's just A plus M. So the operation you are doing is you are just adding 20 plus 34, and then the result is what? The summation is 54, right? Now, tell me whether after this addition is done at line 2, in the line 2 the addition is, you know, we are doing the addition, right? After you are doing the addition in line 2, do you think the n flag will be set? What is the n flag? Negative flag, right? Will it set? No, right? Because look at the summation. That's 54, right? It's a positive number, right? So n flag will not set. What do you think? Do you think the condition is met? What is the condition? The condition is n flag should be set, right? N equals to 1. That means n flag should be set, but n flag is cleared right now. It's not set. So meaning the answer should be no. Remember, as I said, the only thing that we are asking here is whether the branch will occur or not. So this is a yes-no question. So the answer is no. Okay? Let's try another example. Little bit more exciting one. Let's see. So still we have 3 lines. Remember, don't go by those words, full, but that's just, you know, a label, okay? We don't know what the label is. We'll look at the label soon, but let's assume this is a label and that's somewhere in the program, okay? Because let's say you are looking at a program of like 100 lines, 500 lines. Somewhere you have the label. Now, let's look at the 3 line again. In the 3rd line, you have the branch instructions. So we always want to find the test condition, right? From the column 3. Now, in the column 3, this is your test condition. Z plus parenthesis n exclusive or V, close the parenthesis, equal 1. Meaning, this whole thing should be 1, right? Now, let's look at what's going on here. So you are loading a data which is 20, right? Into accumulator B in the first line, right? We know this, right? In the second line, we are subtracting another data which is 30, which is given in the instruction because that's immediate. So all we are doing is we are doing a subtraction like this. 20 minus 34 in second line, right? After the subtraction is done, we got the difference which is EC. You know, we know how to get all of these. Let's check what flags are set. Since, you know, this will be a borrow, right? Because you are subtracting a larger number from a smaller number, so there will be borrow for sure. So the carry flag is set. Z flag is not set. N flag set because the number is negative. V flag will not be set because in case of subtraction, both numbers should have different sign, right? So both numbers are positive. You see the 20 and 34, both of the numbers are positive, so the V flag will never set, will not be set. So this is what we have right now. So we have to determine whether the branch will occur at 3rd line or not, right? And this is the condition. Now let's check the condition and see how we calculate the condition. Look at this. I just plug the values of z, n, and v into the equation. Remember, we have given an equation, right? I'm saying expression and equation. You can say equation because it's left side and right side both. So I plug the n here. plug the z, n, and v. So remember, 1 exclusive or 0. How much you get? Exclusive OR gives you high when both of the inputs are different, right? Digital circuit. Exclusive OR gives you high when both of the inputs are different, right? So this will be high here, right? And also you have a 0, so meaning 0 plus 1, which is just a regular OR. You know, the regular OR gives you high because one of the input is high. So at the end, your condition is met, right? Look at the condition at the right side. What was the original condition? This is the next line I wrote the condition, right? So the condition is met because this expression now is generating 1, which should be which was the condition in the column 3. Since the condition is met, branch will occur. So all these are coming from the flags. All you need to do is just look at those lines and see what operation you need to do, and based on that operation you will know exactly what flags are set or not, right? You know, by this time we already know what flags are set because we just did the quiz 6. Now once you know all the flags, you can calculate excuse me, the testing condition you have in the column 3. Now the test condition will exactly tell you whether the branch will occur or not, right? It's easy. Now and again, this is a list of all the branches, and in the right side excuse me, I also wrote the testing condition, which is also available in the column 3. But one thing is, you know, based on how the branch conditions are, we have some of the branch considers our number as the unsigned number. You know, the number we write, in general those are signed, but based on how it is calculated, some of the branch takes it as an unsigned number, some of the branch consider it as a signed number. So the easy way to understand it is, if you see in the branch testing condition, if you see either in the condition you have N or V flag, you see all these conditions have N or V in the condition. Those are the signed branches, meaning those branch consider the number as a signed number. If in the condition you have N or V, I'm saying in the condition you have N flag or V flag, you see all these conditions you have whether N, you have either N or V or both, or you know. So if you have somewhere the other N or V flag, those branches are considering the signed numbers. If there is no N or V, like these ones in the second category, you see these are only taking like C or Z, those are the ones which are unsigned. If you have some branches like these last two which are only taking like only Z, nothing else, those can both take signed or unsigned. Okay? No. You don't have to do anything. All you need to know is which branch is considered the signed numbers, which branch considered the unsigned number. That's just a list of all the branches. Okay. So in the next quizzes, which is quiz 7 and also quiz 8, you will be answering some question based on the branch. So pretty much you will be given a couple of lines and you will see what is happening in each and every line, and whenever you hit the line with the branch, all you need to do is just to check whether the branch will occur or not. Okay, in quiz 7 it will be just the yes no question. You will just say yes, the branch will occur, because the condition is met, right? And how do I know the condition? Because the condition is given in column 3 of the set of instruction for each branch, right? We'll know the condition from there, we'll calculate the flags, we plug the flags into the equation, and we'll know exactly whether this is making 1 or 0, okay? And based on that, we'll determine whether the branch will occur or not. At the end, you will just say yes or no, okay? And So once we are done, we'll come to our next step. So far what do you know? Based on that, we can answer pretty much all the questions we have in quiz 7, okay, which is just right after the quiz with flags. I know that most of you are done with the flags, right? Most of you are. So let's try the quiz 7 and let's see if you understand it. Once we do that, we will jump on to the next one, just like our branching.